Here we have the standard alternator off my R32 engine. It's a 120 amp Bosch alternator. Well, maybe the regulator's been replaced, so it's made by RTX. But it's same. It's a factory replacement regulator from when it failed previously. So currently I have the alternator hooked up to a battery, and you can see on the multimeter there we got 12.86 volts. What I'm going to do is spin up the alternator with a drill. So I've got a drill here just with a chuck and a M10 XLN spline just going straight into the pulley of the alternator. I'm going to spin it up, and then I'm going to hit the excitation wire, and you'll hear the load of the drill change because it will start charging the battery that the alternator is connected to. You'll hear the load, hear the drill bit, the drill labour, and the load will change, and the voltage will go up to its nominal charging voltage, or thereabouts. It's not going to reach maximum regulator voltage because the battery's not going to be completely fully charged, so there'll be a little bit of voltage drop. But hopefully you'll see what this standard voltage is, and then after I've tested the alternator like this, I'm going to remove the alternator and modify it with a diode to increase the voltage up to 15 volts. I'll get into the reasons why I'm doing that later, but we'll test the alternator now and see what the voltage is. So we'll just start spinning it up gently. You don't want to stop suddenly because the inertia of the alternator will come straight back into your wrist holding the drill, so you want to be careful. Just spin that up to speed there. You hit the excitation, you'll hear the note change. There it is. It's now gone up to 14.5 volts. That's good. The alternator's working nicely. Currently charging the battery from my drill. That's lovely. We'll just spin that down. And there we are. The battery will now relax back to its post-charging state around about 12.8, 12.5 volts. So the alternator's working. So now we're going to pull the regulator off the back of the alternator and see if we can make a modification. Just pop these two nuts off the back of the regulator, because it all holds the plastic casing of the regulator on. Two little spring washers in here. Come on. There we go. Jesus. And then you've got a couple of Phillips screws in the back here. Let's get that in shot. One there. One there. And I think you can... Oh no, these two here are for the regulator, but you have to take this one off at the top to take this cover away. Then once you've got the cover plate off, you can see the regulator tab here, which is the one we're interested in, because this takes the feed from the alternator and it's the reference point for the regulator. And how it works is this is monitoring through a potential divider, so two resistors giving a reference voltage, which then is fed back into the brushes to change the excitation in the rotor. So if you modify the voltage seen by the regulator here, what you effectively do is you skew the voltage that the regulator sees, so it ramps up the field windings a little harder to give more magnetic field to increase the output voltage, because the regulator thinks that it's seeing its optimal charge voltage. But I'm trying to increase the voltage seen to the regulator by half a volt. I'm decreasing the voltage to the regulator by half a volt, so it increases the output by the same amount. It's a 1-to-1 ratio. So we're going to try a few different diodes here, see what works, see what doesn't. What I'm thinking I might try and do is make these connections external to the alternator, so just bring this out and then feed it back in here, maybe make a small hole with a wire that goes through there. Some way of breaking this connection between the stud and the lug and passing it through a diode pack to get my desired voltage. And if I'm thinking if I put something like these little nice fuse holders that I have somewhere on the case here, and then modify the fuse, change it for a diode, then that should be able to give me some adjustment on the output voltage without having to pull the alternator off. I can just literally pop the fuse cap off like that, change out what will be a diode pack, and go that direction. But we'll see. I'll see if it's possible. I think that will be the neatest option here, so we'll give that a go. So there's the first diode, soldered in between the blade of the fuse. Obviously I'm going to cut the link out. It's just to see the link in the middle of the fuse is still there. I'm going to cut that out once the diodes are soldered in. It's just to hold the pieces of metal in the rough shape, and that should fit in there quite nicely with a little fuse holder. So we'll solder this next diode on. The reason I'm using two diodes, I'm using them in reverse bias of each other. You can see the different way around. Let's just bring this up to the camera. So I'm soldering one way and one the other way. The reason I'm doing that is it keeps the voltage more stable, because it's not going to have any flyback or weird variations in the voltage between the regulator and the reference point. So I'm soldering them in the reverse bias. You probably don't need to do that, but it's just a little safer, so I'm putting both on. There we go. That should be okay. Ow, it's still a bit hot that side. We'll grab it the other end. It should be okay now. There it is. Two diodes. A little ugly, but I ain't one to judge. Let's give it a whirl. So we've got the diode pack sitting pretty inside the fuse holder here. It's just a simple, basically a replacement for a blade fuse. Obviously I cut the link out the middle of the fuse, so between here and here is 1/2 volt difference. So we're going to plug this in, and then that fits nicely inside this little fuse housing here. And then I'm going to bring this tab here straight upwards and melt a hole through this piece of plastic here. I don't know how well that's going to look, but I'll give it a go. I might solder it, I might just put a spade lug on, I'm not sure. And then this wire is obviously going to come around somewhere like that, and then meets up, well, whichever way it goes, onto the that side, and this will come back round to where it used to go internally. Something. It will go some way like that. So we're gonna, I might swap these wires over actually. Shouldn't be too hard to do. So I've got the longer one on the inside. We'll see how it sits. But yeah, that's pretty much the premise of my idea. Anyway, I'm going to bring this out and have this with a ring lug going to here, and this will come out and go through this one, and that will give me a voltage difference. What I've done there, hopefully you can see, is cut it into a rough kind of spade shape. I had to crop a little bit off the left hand side there. You can see that little indent, so that this push on will fit on there nice, and it'll go like that, so that once the case goes back on, goes this way. So it goes back on there. It just leaves this exposed just enough. They'll be able to get this spade on there. I'm going to have to melt a little bit more plastic out for the insulated one, but that's okay. So I'm going to melt a little more plastic away, and then this will sit on there. This wire will go in there. Mod complete. So I'm just going to melt that a little bit more plastic out. So, let's see, which way does it need to go? That way. Take a little out the bottom, and at that side. Okay. Put that back on. Just try this on there. I need to bend this away. Unless it's, yeah, just gonna give it a little bend. Hopefully they don't break. Yep, that should do it. And put this back on. Try again. Looks more central now. Just put that in there. It's tight. I'll give it that. It's tight. Not too tight. But with a little tweaky. Might have to go a little more this way. Just a little more close to this, because it's quite a way out. It's not a fine science, this one. It's literally chisel away till it fits. Not too much. And there's my tight friction fit. Wow. Goes on. Quite far down enough. Still not quite right. Ooh, I've broken the plastic now, but it shouldn't matter once it's on. Yep, it's now on nice and all the way down. So there's that, and that's just going to go in there, crimp that on, and that'll be it. Let's give this a, it's going to squeeze this ever so slightly, so it's less likely to wriggle loose. And then cut this, and strip, and crimp. That's going to go in onto the spade. There she is. And probably what I'll do is I want to secure this wire slightly so it's not wriggling around too much. It should be okay. Don't think it's gonna, its termination's pretty secure, it's not going to go anywhere. Right, so with that back housing on, we can put the screw back in here, nut on, this nut with the ring, and the battery one's going to remain off for the minute for testing. Let's do that now. Click. And that's it. One modified alternator. I'm going to give it a little test and we'll see what voltage we get. It should be half a volt higher than standard. I'm hoping for about 15. It can be a little over. Alright, Rooney. So, on the field excitation winding, on my particular regulator, alternator wiring, I don't know if they change, but the excitation is at the round end of the connector. There's only 2 pins in there. You can't really see it that well, but there's only 2 pins, and it's the one in the round side. Just going to clip that onto a wire. This is my excitation. So once the alternator is excited, you don't need the 12 volts on there anymore. It will keep itself excited. I'm going to use just a little extension, it's quite simply a bolt with a nut on the end, just for popping onto the battery terminal there. It's just enough to get a clip on it, because I'm going to use big crocodile clips going down to my battery, so just clip that on there. Yep. And alternator ground is simply the chassis of the alternator, which normally grounds to the engine block. Shift that back away. So just strap that onto the ground, one of the mounting lugs of the alternator. I'm going to spin this up, and then I'm going to touch this excitation wire here onto 12 volts, and it should start loading as it did before, and we'll see what voltage we get. Start spinning it up. The voltage doesn't change until I hit the excitation. Oh, there we go. 15.3. Perfect. 15.3. I'm a happy man. Now, I'm going to get on to why I'm doing this. Okay, so in my car, you may have seen in my previous videos, well, one of my videos, I made a capacitor pack. So I don't have a battery in the car. That's why I have a support battery, which is what I'm using for testing the alternator. It has an Anderson plug on each end, and I normally connect the car to the Anderson plug of the battery when I'm in the pits at the track. That's if I need to do any diagnostics on the car, or if I need to run the fuel pump for a long time or whatever, because the capacitor has a very small capacity. It's about 1/100th of the size of a regular car battery. It's 333 farad across the bank of 6 capacitors, which have a total voltage rating of 16 volts. So I have decided to increase my alternator voltage because I can safely charge those capacitors up to 16 volts with no detrimental effect. I wouldn't recommend running such a high voltage. You could use a Schottky diode or something like that, which has a lowered forwards bias and allow you to increase the voltage to a little more than standard. But I wanted to go for just over 15 volts because I can run up to 16. It gives me a nice safety overhead, and the capacitors have what they call balancing boards across the array, which monitors the voltage across each cell, and if they exceed their maximum of 2.8, I think 2.81 is their absolute maximum. Once it gets up to that sort of level, the balancing board will actually create a small load across the capacitor and clamp that voltage down and stop it from overvolting the cap, preventing any damage. So this should be a nice safe mod for me, for my setup with the capacitor and everything. And what it ultimately leads to, and the reason I'm doing this, is the engine will start faster because of the higher cranking voltage. The ignition coils will have a higher output because they obviously see a higher voltage at the primary of the coil, which means you will get a higher voltage at the secondary coil when they trigger. So that equates to more spark energy, less chance of blowing the spark out on my boosted 3.2 VR6. And the injector dwell time goes down as well. So my injectors are more responsive, they open quicker, hopefully delivering a nice, rapid, consistent stream of fuel. So, oh, and the fuel pump will also increase its output slightly because I'm effectively overvolting the fuel pump. So instead of it seeing 13.6, 13.8 volts, it's now going to see over 14. After all the resistors to the wiring, it probably nearly 15 volts, which is perfect, because that ultimately allows my Walbro 450 to flow more than it would at standard voltage. So it's all beneficial. It's for my setup, it is a great way of increasing the voltage to the whole system. You have to be careful. You don't want to exceed. Damn birds. Sorry, the birds in here are going crazy. So I don't want to exceed obviously 16 volts because that will be damage territory for the capacitors. If they were overvolted for a long time, that's not going to be good for them. And also the ECU becomes a consideration once you start approaching over 16 volts. So you have to be careful. You don't want to go too crazy on the boosted alternator voltage here. My lead acid won't suffer too much of that, because if you put the lead acid on 15 volts or 15.3 I got, you're going to bore your battery. Basically, most lead acids are not designed to be charged over sort of 14.2, although some factory alternators do that and they ramp their voltage down once they've fully recharged the battery, because the higher the input voltage is, the quicker the battery's going to charge. So that's basically the summary. Hopefully the video is helpful if you're looking to increase the output voltage of your Bosch alternator. If you liked it, subscribe, like the video, it all helps me out, so appreciate it. Thanks for watching.